Welcome to Math Tutorials. In this video, we are solving every question of exercise 1.2 of Chapter 1, Relations and Functions, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 1.2 has 12 questions, all about two properties of functions, 1 also called injective and onto also called surjective. Here are the 12 questions. Let's start with question 1. Question 1. The reciprocal function, 1 over x, on the non-zero real numbers. We must show it is 1 and onto. And then the twist. Does it stay 1 and onto if the domain shrinks to just the natural numbers? 1 first. Suppose f of x1 equals f of x2, then cross-multiplying forces x1 equals x2. Onto, any non-zero real y is hit by its own reciprocal, which lives in the domain. Now shrink the domain to the naturals. Distinct naturals still have distinct reciprocals, so f stays 1. But take y equal to 2/3. We would need x equal to 3/2, which is not a natural number. Onto fails. Question 2. We must check injectivity and surjectivity for two formulas across different domains. Parts 1 to 3 take f of x equals x squared. On the naturals, the integers, and the reals. Parts 4 and 5 take x cubed. On the naturals and on the integers. Part 1, x squared on the naturals. Two distinct positive numbers have distinct squares, injective. But 2 is not a perfect square, so nothing maps to it, not surjective. Part 2, x squared on the integers. -1 and 1 share the same square, injectivity is lost. And squares are never negative, so -1 is never reached, not surjective. Part 3, x squared on the reals. The very same two counterexamples apply, so it is neither. Part 4, x cubed on the naturals. Cubing preserves order, so distinct naturals give distinct cubes, injective. But 2 is not a perfect cube, not surjective. Part 5, x cubed on the integers. Cubes keep signs and order, so still injective, and 2 still has no integer cube root, so still not surjective. Question 3. The greatest integer function assigns to x the largest integer, not exceeding x. We must prove it is neither 1 nor onto. Not 1, 1.2 and 1.5 both round down to 1. Two different inputs, one output. Not onto, the outputs are always integers. A codomain value like 1/2 is never achieved. No real number rounds down to 0.5. Question 4, the modulus function. X maps to its absolute value. Again, we must show it is neither 1 nor onto. Not 1, -1 and 1 both have modulus 1. Not onto. A modulus is never negative, so a codomain value like -1 is never reached. Question 5, the signum function. 1 for positive numbers, 0 for 0, -1 for negatives. We must show this too is neither 1 nor onto. Not 1, 1 and 2 are both positive, so both map to 1. Not onto, the only outputs ever produced are -1, 0 and 1. A codomain value like 1/2 is never attained. Question 6. A is the set 1, 2, 3, and B is the set 4, 5, 6, 7. F is given as an explicit list. 1 to 4, 2 to 5, 3 to 6, and we must show it is 1. The images of the three domain elements are 4, 5, and 6, all different. No two inputs share an output, and that is exactly the definition of 1. Notice it is not onto, though nobody asked. 7 in the codomain is never reached. 1 and onto are independent properties. Question 7. For each function we must decide, 1 onto or bijective. Part 1 is the straight line 3 minus 4x. on the reals. Part 2 is 1 plus x squared. Part 1, the line. Equal outputs force equal inputs after dividing by -4, 1, 1. And any target y is reached by x equal to 3 minus y over 4. Onto, so part 1 is bijective. Part 2, the parabola. -1 and 1 both give 2, not 1, 1. And outputs never dip below 1, so 0 is unattained. Not onto, part 2 is neither. Question 8. For any sets O and B, the swap map sends the pair AB to the pair BA. We must show it is a bijection from a cross B to B cross A. 1, 1. Suppose two pairs have the same image, so B1, A1 equals B2, A2. Ordered pairs are equal only component-wise. B1 equals B2 and A1 equals A2, the original pairs were the same pair. Onto, any element of B cross A looks like BA, and it is the image of the pair a B from the domain. Every target is hit. Question 9. On the natural numbers, odd inputs step up by 1, even inputs step down by 1. Is this function bijective? We must justify the answer. Watch what the function actually does. 1 goes to 2 and 2 goes to 1. 3 goes to 4 and 4 goes to 3. It swaps the naturals in neighboring pairs. 1, 1. An odd input lands on an even output and vice versa, so two equal images must come from the same parity. And within one parity, n plus 1 or n minus 1 equal forces the inputs equal. Onto, every odd number m is the image of the even number m plus 1, and every even number m is the image of the odd number m minus 1. Everything is hit. 1, 1 and onto, F is bijective. Question 10. A is the reals without 3, and B is the reals without 1. The function is x minus 2 over x minus 3. Is it 1, 1 and onto? 1, 1. Set f of x1 equal to f of x2 and cross-multiply. Expand both sides. The x1, x2 terms and the constant 6 cancel, leaving minus 3x1 minus 2x2 equals minus 3x2 minus 2x1, which simplifies to x1 equals x2. 1, 1. Onto, take any y in B and solve y equals x minus 2 over x minus 3 for x. Multiply out, gather the x terms, and divide by y minus 1, allowed, since y is never 1 in B. This x is a real number, and it cannot equal 3, that would force 3y minus 2 to equal 3y minus 3, which is impossible. So x lies in the domain and maps to y. Onto. Therefore, f is 1, 1 and onto bijective. Question 11. The fourth power on the reals. Is it 1, 1, onto both or neither? An even power forgets signs. Minus 1 and 1 both map to 1, not 1, 1. And a fourth power is never negative, so minus 1 in the codomain is never attained. Not onto. So f is neither 1, 1 nor onto. And question 12, the last one, multiplication by 3 on the reals. Is it 1, 1, onto both or neither? 1, 1, if 3x1 equals 3x2, dividing by 3 gives x1 equals x2. Onto, any real y is the image of y over 3, so f is both 1, 1 and onto, a bijection. That completes exercise 1.2. That completes all 12 questions of exercise 1.2. In the next video, we will take up the miscellaneous exercise of Chapter 1. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.